Vector and commercial calculus. Vector and commercial calculus. Probably we have reached till end one or two sessions that we will take. Vector and commercial calculus. Mind blowing, amazing. Okay, anyway, in vector and commercial calculus, we are in phase of calculating flux through flux density. If I know flux, if I have flux, if I have flux, then through flux I can calculate flux density. If I have flux density, then through flux density I can calculate flux back. So that is the discussion. What is flux? Many times we have reiterated flux is if there is a liquid that is flowing through a surface, then liquid velocity I know, surface area I know. Then how much is the liquid volume of the liquid that is coming out of the surface is called flux. Volume per second. That is called flux. Okay, so this is the definition for the flux. How much is the volume that is coming out of the surface per second? That is the flux. Okay, like if there is a kind of drum, there is a drum, or there is a kind of on the rooftop people they keep water tank, and then through pipe water is going inside the water tank, or there is a drum through which water is going. How long it will take to fill up the water? Or if I know the water is getting filled, this is 100, I'm sorry, 1000 meter cube of a tank. There is a tank that is 1000 meter cube, 1000 meter cube, and filling the tank takes 100 seconds. Up, 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 up. In 100 second, in 100 second, one 1000 meter cube tank is getting filled. Now through pipe, water is coming at constant velocity. If pipe cross section, the pipe cross section is zero point 0.5 meter square. Makes sense? 0.5 meter square. Zero point 0.5 meter square, how much it will be? Okay, that is pi, the cross section of the pipe is zero point 0.5 meter square. That is pi r square equal to zero point 0.5. Pi equal to 3.14. If someone divide whatever comes, then take the square root of it, then it will be that much is the radius. I don't know how big it would be. So consider the zero point 0.5 meter square is the area of the pipe, cross section area of the pipe. What is the velocity of the liquid? Okay, very simple, right? So when pipe, consider pipe is like this and water is coming like this. There is a tank like this. Hop, hop, hop. Okay, there is a tank like this. Hop, hop. This is 1000 meter cube tank. Okay, and water is falling in this through a pipe, and pipe cross section area is zero point 0.5 meter square, and this is the velocity of water or a liquid that is flowing through the pipe and it is filling the tank. Now if that is the case, then what is the velocity of the liquid when it is filling in 100 seconds? If that is the case, then flux means how much is the volume per second coming out. Then if it is taking 1000 meter cube, 100 second it is taking, then 10 meter cube per second it is flowing out. So velocity vector dot product with the area vector is the net flux. Velocity vector means water is flowing like this, liquid is flowing like this, and pipe cross section, hop, 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 pipe cross section area is like this. Means the area vector is perpendicular to the surface. So area vector and velocity of the liquid are in same direction. In that sense, velocity vector dot product with the area vector equal to the flux. Flux coming out is 10 meter cube per second, because 1000 meter cube tank it is taking To fill the tank, it is taking 100 seconds, 10 meter. And okay, so velocity is 10 by zero point 0.5. Then velocity is 20 meter per second. Very high, right? So in 1 second, the liquid is flowing 20 meter. So 20 meter per second is there. People can calculate like this. Okay, this is this is called this is called flux calculation. Flux means what is the volume of the liquid that is passing a surface. That is called flux. Okay, all right. Okay, nice one. Now consider consider that I take a tank. I take a tank like this, and from the top of the tank, pipe is there, and from the bottom of the tank, there is again pipe here. Top of the tank, pipe is here, and bottom of the tank, again pipe is here. Now, liquid that is flowing from here, that has some velocity, and pipe has some cross-sectional area, and then tank is getting filled or whatever. Now, when liquid is coming out of bottom, it has same cross-section area and same velocity of water is there. Okay, if that is the case, then this makes a volume. Earlier the flux, what is the flux of the pipe? Flux of the pipe, when liquid is coming out of the pipe, then it is like I can just think about one area is there. The pipe will be circular, and down there is one area is there. Velocity into area. So flux coming out is 10 meter cube per second. Now, if filling a tank and from tank there is a pipe and again the liquid is dripping at same speed, what is the net flux of this tank? Hop. What is the net flux of this tank? If liquid is coming out at the same speed liquid is going out, the net flux. Flux means how much is the liquid that is oozing out of the surface of this tank. That is called flux. Flux means flux is calculated against a surface. Flux is always calculated against a surface. If I have a spherical volume, then what is the flux of it? Flux will be calculated against top surface plus bottom surface plus this curved surface. Okay, net flux is zero. Zero in the sense whatever the flux is coming in, same flux is going out. No flux is there is no flux at all. How you say there is no flux? Can you calculate? Yes, I can calculate. Okay, okay, to calculate the flux. Now, now consider this is x-axis and this is y-axis. This is z-axis. This is x-axis. This is y-axis, and this is z-axis. If that is the situation, then this cylindrical is kept at the origin. Many times I have given this example. Now liquid is entering along x-axis, coming out along the x-axis. Now I say I have a surface, and that is the boundary surface of a cylinder. I have a surface, and that surface is a boundary surface of a cylinder. Okay, if that surface is a boundary surface of the cylinder, then it has three boundaries. One boundary, second boundary, and third boundary. If that is the scenario, what is the flux coming out of it? Then flux that is coming out of it is velocity of the liquid dot product with this surface. If I say all the surface of this cylinder is outward, the orientation of any surface can be two-way. Okay, I believe there is something called a Moby wand or something like that. So it does not have a kind of orientation of the surface. Okay, that we will see. But a surface is oriented. Surface is oriented in the sense that any surface has two directions. If this is the surface, then okay, if this is the surface, consider this is very flat, very thin. Now it has two sides of the surface. This surface is oriented in a fashion that it is like this. Okay, this surface is oriented in fashion. This is called surface direction. So similarly, if I say that I have a cylindrical surface, it has three surfaces, they are oriented outward. Means this surface normal is along this direction, but this surface if I take out, normal can be along this direction also. Then I can say that the right hand side of surface, orientation of the surface is inward, but we say that cylinder has surfaces oriented outward. The surface is oriented outward. The surface is oriented outward. Surface vector is perpendicular to the surface. And then this surface is oriented outward. All three surfaces are oriented outward. Then you calculate the flux. If liquid is entering from here, velocity vector dot product with the surface area vector. Surface area vector is in minus x direction and velocity vector is in x direction. If dot product, if we do dot product of it, then it will come as a negative. Similarly, if velocity is passing here, then liquid velocity is in this direction and surface is also in this direction. Then it is altogether positive. Positive plus negative, it will tend to zero if surface area is same and velocity of the liquid is same at both sides. Anyway, we have seen it. What is the here? It is perpendicular. Velocity is perpendicular to the full surface vector. Then it is zip. Okay. So only flux is here and here. Flux is negative here. Flux is positive here. At the end, it is zero. Net flux is 0. Okay, we have calculated net flux is 0. Net flux can be positive when if both surface area is same, liquid velocity is entering here is less and liquid velocity, or liquid is entering here at some velocity and liquid is coming out from here at higher velocity. If that is the case, then net flux is positive because here net flux is x, then net flux here will be x plus y because velocity at which it is coming is higher. So flux will be higher minus less here, net flux will be positive. Flux from any surface, flux from any closed surface is the capacity of a liquid that is oozing out of the surface. So if this is the surface, closed surface, how much is the liquid that is oozing out of the surface? That is, what is the liquid that is oozing out of the, from here there is no liquid oozing out because what liquid is entering along the x-axis. This is x-axis, y-axis, z-axis. So liquid is oozing out from here. Liquid is entering from here. If you add both or subtract, the net liquid that is oozing out of the full surface you can calculate, divide by the volume called flux density. Or how much is the liquid entering from here, liquid getting out from here. If you see the change in the velocity, d, d, d velocity by d distance. Okay, if liquid vector is f vector, if liquid vector is f vector, if liquid vector is f vector, df by dx along x-axis, how much liquid velocity is changing? If it is changing, then it is giving a scenario of a positive flux. Flux density. Flux density means how much is the liquid oozing out of the surface divided by the volume of the surface. Divided by the volume of the surface. Or this is called flux density. So flux density is calculated at any particular point. If it is centered at the origin, what is the flux density? Because if I calculate flux, then it talks about the full surface area. Surface area is directly proportional to how big it is, or what is the volume of this. If volume is bigger, then any cylinder centered at the origin, any cylinder centered at the origin, the cylinder volume is bigger, flux will be bigger because area is bigger. If you divide by the volume, you normalize it. That is called flux density at the origin. Flux density is net flux coming out of the surface of a closed region divided by the volume where volume tends to zero. Means we are calculating at a point, or liquid is entering, then how much liquid velocity is changing along x-axis, df by dx. If liquid is passing in any direction and it has component as F1, F2, F3, the liquid velocity is F vector equal to F1I plus F2J plus F3K, then the net divergence, now we come to divergence at a particular point, that is dF1 by dx plus dF2 by dy plus dF3 by dz. Anyway, divergence and flux density are same. Either you calculate the net flux for a volume surface, divide it by the volume, or you calculate dF1 by dx plus dF2 by dy plus dF3 by dz. Anyway, if that is the scenario, then so this is called flux density or divergence. Same. Okay, we have proved it long back how flux density and divergence are same thing. Anyway, if they are same thing, flux density and divergence are same thing, it is very simple to calculate. You take a small cube of size delta x, delta y, delta z, keep it at the origin. Keep it at the origin. Okay, then one side will be minus x, minus delta x by 2, one side will be delta x by 2, minus delta y by 2, delta y by 2, minus delta z by 2, delta z by 2. Now take any velocity vector has component f1, f2, f3. Now calculate the flux along all the sides, then divide it by the volume, that is delta x, delta y, delta z. It will come as df1 by dx plus df2 by dy plus df3 by dz. So divergence or flux density. So divergence, generally people say at any point what is the divergence? At that point, what is the tendency of any energy source to propagate energy from there? If liquid is entering here, it is centered at the origin. At the origin, there is an energy source out there from which liquid is diverging. That's why liquid that is coming out has more velocity, because liquid is getting added at the center. Okay, if I say the liquid velocity is minus xi, then at the center, liquid is coming from x-axis and y-axis toward the center. If I say liquid is xi, then from the center, liquid is going out in the x direction. Minus x and x. Minus means opposite. In mathematics, minus means opposite. If at the center, if I say xi is the velocity of the liquid, then liquid along x-axis, liquid is going towards x-axis. Liquid in minus x-axis, liquid is going toward minus x-axis. If liquid velocity is minus xi, then from minus x-axis, liquid is coming to the center. From x-axis, liquid is coming to the center. So, if divergence is 0, means velocity vector of liquid is either static vector like ai plus bj plus ck, all are all are all are number. Then df1 by dx plus df2 by dy plus df3 by dz is 0. Or altogether summation is 0, like if it is a algebraic vector. If it is a constant vector, then divergence is 0, because velocity is always in one direction with constant, no change in that. But if it is a variable vector, at every xyz vector direction and magnitude is changing, then their component in xyz differentiation addition should lead to 0, like minus xi plus y by 2 j plus z by 2 k, df1 by dx plus df2 by dy plus df3 by dz. If you add in minus xi plus y by 2j plus z by 2k, it will come as 0 again. Anyway, now we are in different mood today. So mood here is that if I have a divergence, okay, Visual divergence is here. Okay, so idea is if I have a divergence, okay, I calculated divergence from the flux. So nicely, right? Calculating divergence from the flux at any point, calculate df1 by dx plus df2 by dy plus df3 by dz. F is the vector field or velocity vector. Calculating divergence or flux density is at any point is take a closed surface around the point like a sphere. Calculate the flux out of the sphere because of that velocity vector. Divide it by the volume, you get the same amount. I am giving the flux density now. Flux density is being given from outside. Then calculate the flux. Flux density is given, then net flux coming out of any surface. If flux density is provided in that region, I'm sorry, at any point, If there is any point flux density is given, then around it, if I make a surface, then how much is the net flux coming out of the surface? Flux density into the volume of the surface. Makes sense, right? Flux density is flux by volume, then flux is flux density into the volume. But if flux density is algebra, df1 by dx plus df2 by dz plus df3 by dk is algebra. Can you give example? It will be algebra. I can give example. X square I plus y square j plus z square k. This is the velocity vector. Divergence will be 2x plus 2y plus 2z. This is algebra. If the flux density d is function over x, y, z, if I am trying to calculate the net flux, flux density into the volume is the net flux coming out of the surface. If I am calculating flux density at point 2 comma 2 comma 2, okay, if flux density what I have calculated, or consider flux density I am giving with this formula, that is 2x plus 2y plus 2z. There is a sphere, there is a sphere and it is centered at the origin. Now, because of this flux density, calculate the net liquid that is oozing out of this sphere. It has radius as r. Okay, if it has radius as r, then volume of the sphere is 4 by 3 pi r cube into the kind of flux density, that is 2x plus 2y plus 2z. Okay, it will not work, because if flux density is variable over x, y, z, now every point flux density is 0. At origin there is no flux density. At 2 comma 2 comma 2, flux density is like that. Means substitute 2x plus 2y plus 2z at 2, 2, 2. I believe it will come as 12. Everywhere flux density is different. In that sense, if I'm trying to calculate flux coming out of a sphere, direct multiplication will not work. In that sense, we have to go with integral calculus when we want multiplication. Multiplication, if I want between two entity, then indirectly we are trying to calculate area of a rectangle where one is width and one is height, where height is dependent upon the width. This multiplication will lead to calculation through integral calculus. Then it becomes density function into volume replaced by density function into d of volume, where d of volume has x, y, z, where volume will be 0, volume will be volume 1 to volume 2. Mind it, whatever I am saying it is a trillion. Nowadays, everywhere $1 trillion is coming into the picture. So $1 billion and $1 million era is over. Trillion dollar. This is a $1 trillion explanation. Okay, if I'm trying to multiply vector field F, I'm trying to multiply density, flux density with the volume. Then flux density is height. If I'm trying to calculate area of a shape which has a height and a width, then it is height by width. That is the area of the shape. If height is constant and width is constant, just multiply it. If height is constant and width is variable into x, again you can multiply it. Later you can change the x value with someone, you get the area. But if height is function over x, then direct multiplication will not work. It is called pseudo multiplication. If height is function over x, then height is fx, where height will keep changing as we move along x axis depending upon the function, like sin x. Sin x at the origin is 0, then height will grow, height will come down, height will go negative, it will come down. Like that. Negative means opposite direction. Okay, anyway, but it is shown like this in graph. Negative is going down. No one will go down, don't worry. Anyway, so if that is the scenario, then if someone try to calculate the area of sinusoidal curve, then area is not rectangular, but still we say fx into x is the area. Someone will contradict that it is not fx into x, then someone say fx into dx, that is the area. Similarly, if I have a kind of flux density into volume, is the net flux. Flux density is the height. Flux density is function over fxy. Flux density is function over volume or whatsoever. So flux density f is function over x comma y comma z, or function over volume. d of volume. If I calculate, similarly, if I have x-axis and function over x-axis is some graph, and if I want to calculate the area between a point called x1 and x2, and this is fx, then fx dx x1 to x2. Similarly, here density function is fxyz d of volume. Volume is from V1 to V2. What is V1 and V2 that you understand? Okay, this is called volume. Volume space. There is something called x-axis. There is something called xy plane. There is something called xyz volume. Only one independent component that is called xyz volume. Only one independent component that is called xy plane. In that x-axis and y-axis is there. Only one independent component that is called x-axis. If there is one independent component, then we call it two dimension. If there is one independent component that is xy plane, then we call it three dimension. If there is one independent component that is called xyz cubical, then it is called four dimension. In four dimension, xyz are independent and density function is dependent. If we are calculating the net weight through density into the volume, then I can go with direct multiplication if density is constant. Otherwise, if density is variable over the volume, the density dV from V1 to V2, where density is y-axis and volume is x-axis. If you multiply any two items, you are trying to get area. One is height and one is width. Okay, if height is dependent upon width, then you go for integral calculus. V1 to V2. If I dissociate it, then it becomes density function dx, dy, dz. That is the v. And then x from where to where, y from where to where, z from where to where. Okay, then you get the flux back. So we can get back the flux back from the flux density, but we have to use integral calculus. If flux density is numeric, flux density is a number, still we can get back the flux. But at that sense it will be direct multiplication would also work. But integration will give the direct multiplication only at the end if flux density is numeric. So normal multiplication is a special case of integral calculus. Integral calculus special case is normal multiplication. So blindly we can use normal multiplication everywhere, normal integral calculus everywhere, even though the integrand or the dependent component fx yz is numeric, still we can use integral calculus. It will end up in normal multiplication if it like that. Otherwise, it will do its magic. This is what the scenario is. Now, I am now progressing into it. Consider that I have a sphere. I have a sphere. This is oriented outward and it has a radius. The sphere has a radius as 1. Radius as 1. At the center of the sphere, one electric charge is kept, and the charge, the net liquid, electromagnetic liquid or electrical liquid that is coming out of the center is q into r vector divided by r to the power 3. R vector, if this is center, R vector all along, divided by R to the power 3. If I talk about the Cartesian coordinate system, then Q vector, Q, that is charge of the electrical charge kept, the power of the charge, Q, R vector, xi plus yj plus zk, divided by x square plus y square plus z square to the power 3 by 2. Then what is the flux that is coming out of this sphere of radius 1? Okay, then what is the flux density? Flux density we have calculated df1 by dx plus df2 by dy plus df3 by dz. Okay, if I calculate the flux density, then it comes as 0. Flux density into the surface, into the volume is the net flux coming out of it. But net flux coming out of it, certainly it is not 0 because flux is coming out of it. The gocha here or locha here is that velocity vector is not continuous at the origin at all. If velocity vector is r vector divided by r to the power 3, when r is 0, at that time it becomes undefined. It is not defined. I want so infinity, it is undefined. Infinity is also defined. Okay, there is a holy book in India called Gita, and in Gita, King Krishna, he talks about universe is infinite. If something is infinite, he never says universe is undefined. Okay, undefined and infinite. Anant is a Sanskrit word that is used here. Anant. Anant means it is the universe is infinite, and there is something called undefined. Undefined is different thing. Infinite means still. If someone, I won't go beyond it because it will do many nonsense if I go beyond it in human civilization. But whatever it is, here it is undefined. If the velocity vector is undefined at any point inside this sphere, then we cannot go with this calculation flux density into the surface area. Flux density into the volume is the net flux coming out of it. What formula I have to use? Then I have to use simple flux velocity vector dot product with the area vector is the net flux coming out of it. Consider there is another sphere. Okay, I don't have another sphere. Consider this is a sphere of radius 1. What is the flux that is coming out of it? Okay, just leave it. Consider there is another sphere on top of it that is also centered at the origin. There is a small sphere centered at the origin. There is a bigger sphere also exactly around it, centered at the origin. Radius of that sphere is 3. Radius of this sphere is 1. Radius of that sphere is 3. If that is the case, this is hollow. This is hollow and radius 1. There is another sphere that is coming around it. That sphere, and between this sphere, there is a solid region that is filled with iron. Consider that is filled with iron, and that is another sphere. Okay, and this is hollow, whatever. Now it makes a kind of a region in between it. Makes sense? This is a Okay, consider this is a sphere hollow. There is another sphere coming out around it, and it has radius 3, it has radius 1. In between, there is a spherical region. That region is filled with iron. Now, at the center of this, the electric charge is kept QR vector divided by R to the power 3. That is the electric charge, velocity vector. Then, then its divergence is 0, right? This is what df1 by dx1. Someone calculate, he will get 0. We have done it already. Then how much is the flux because of the charge? Okay, how much is the flux that is coming out of it? The flux direction is same as area vector direction. So flux velocity vector into the area vector I can take because the direction is same. So dot product will be all right. Cos theta is 9, theta is 0 degree, cos theta is 1. Q r vector divided by r to the power 3 into 4 pi r square. 4 pi r square. Okay, area vector is again along the r unit vector. If r vector here, if I convert into r unit vector, it will be r into r unit vector. Then it will be q by r square r unit vector dot product 4 pi r square r unit vector. Unit vector r unit vector gone, r square gone. 4 pi q is the net flux that is coming out of it. If I just take 4 pi independent of the radius, can you see this? If there is another sphere that is coming out around it, what is the net flux that is going out of that sphere? Only that sphere. Again 4 pi q, whatever. Now, whatever the reason in between, what is the flux that is coming out of it? That is the question. If that is the question, then now we are into a shape of something, shape of a sphere, which has two radius. One radius is r1 and one radius is r2. Spherical region is in between it. Understandable, right? There is a radius r1 and there is a sphere, and there is a radius r2 and there is a sphere. In between there is a filled section that is filled with iron. I want to calculate flux in that region. Flux means in that region there are two surfaces. One surface is the inner R1 sphere, and one surface is R2 sphere. Means that surface I take out, but both surfaces are oriented outward. means inner surface R is oriented outward only. Inner R1, outer surface R2 that is 3 and inner surface R1 that is 1 that is also oriented outward. Charge is kept at the center. If I try to calculate, if if I try to calculate, if that is the condition, if that is oriented outward, okay. Now I am trying to calculate the net flux that is coming. Net flux, if I am trying to calculate, net flux, if I am trying to calculate, no mind it. Now inner radius is R1 and it is like this, and it is outward. If flux is going like this and it is hitting the surface, then it is hitting the surface like this. Then if I try to calculate the flux that is hitting the surface, flux is going inward. Means here flux will be considered as negative as far as that solid region is concerned. Flux means what is going out, but here it is entering, and from outer sphere it is exiting. So if it is entering from the inner sphere, the area vector that will come into the picture is this one, not this one, this one, this area vector, and into the liquid direction. This area vector is negative. If this area vector is positive, then this area vector is negative. Now the net flux that is coming net flux calculation through the for the because the solid region what we are taking for which we are calculating the flux through flux density. So that solid region has two surfaces. Now one surface is outward and another surface is inward somehow, unfortunately. If it is outward, then it will pierce inside the volume only. That we don't want. When we are calculating the flux, we have to see outward vector. This outward vector it becomes negative now. So now flux calculation, if I am trying to calculate flux through flux density, then flux density into this region, whatever is the flux density into the solid region, is the net flux that is coming out of this solid region, that is in between radius R1 and R2, that is equal to flux of the inner surface plus flux of the outer surface. Okay. Oh, it is confusing. Same thing, right? If I am trying to calculate the flux of this cylinder, then flux of, if liquid is going in x direction, then flux for this surface plus flux of this surface and flux of this surface. This surface flux is zero because liquid direction is perpendicular to this area. Otherwise, then flux is this surface plus flux is this surface. This is a solid region for which this surface direction is this and this surface direction is this. Similarly, if I mold it like this, somehow, if I mold it like this, then this inner surface will become inner surface of the R1 sphere and this becomes the outer surface of R2 sphere. Here, this direction will come as negative because this direction was positive, outward, it was outward. So this inward will be negative. Now, what is the net flux around it? It is minus 4 pi q. It was 4 pi q earlier. It is minus 4 pi q. What is the flux of the outer sphere? If I want to calculate, then outer sphere flux minus inner sphere flux equal to 0. Because for this reason I am trying to calculate. So for this reason, just I am proceeding. So the reason between this is the reason I am talking, this solid reason. And if this is the flat, if I mold it like this flat, if this is the flat surface, if I mold it like a spherical, then this is the inner radius. This flat, if I mold it like a spherical, this is outer radius, R2. This is R1. For this reason, that is this reason. This reason, what is the flux, net flux? At the center, the charge is q r vector divided by r to the power, that is the velocity vector. Flux density is 0. If I am trying through flux density, this sphere, if this region, if we are center is, this is origin of the sphere. Okay, if origin is here and we are trying to calculate flux around this region, then this region is not containing the origin. At origin, the flux at the origin, the velocity vector is undefined. But in this region, velocity vector is defined. If velocity vector is defined, I can use the fundamental I can use the fundamental of flux density into the volume. So flux density into the volume is the net flux in this section. Now I know that. What is your question? My question is, if I know the flux that is coming out of here, what is the flux that is coming out of here? I rephrase that question now. The question is, there are two spheres. One sphere is this, that has, this is the center, origin. This sphere has radius r1. This radius sphere has radius r2. At R1, first question was, in between there is a iron region. What is the flux that is coming out of this iron region? Flux that is coming out of, what is the flux that is coming out of this sphere when the sphere vector is area vector outward, that we calculated as velocity vector dot product with the area vector, that came as 4 pi q. What is the kind of a flux that is coming out from this surface? It is again 4 pi q, whatever. So this story is over. Now next story is, what is the flux in this region, in middle region? What is the flux? Okay, I did not calculate the flux from the flux density. Flux is flux density into the volume. But problem with both sphere were they were centered at the origin, and at the origin the velocity vector is not continuous. But now the reason for which I am trying to calculate the flux, this region does not have origin. Origin is at the center, but this region is in between. In that case, I can use net flux calculation, flux density into the volume. Whatever is the volume is, flux density is zero. Means in this region, the flux density is zero. Flux. So net flux in the central region is nothing but flux on this. Net flux coming out of this volume is flux at this surface plus flux at this surface plus flux at this surface. Similarly, if I am trying to calculate flux at the middle region of two spheres, then flux will be flux at the inner surface plus flux at the outer surface. Consider now, I know that flux inside the inner region is zero, because inner region in between two spheres is not containing the origin. I can go with the formula flux density into the volume. Flux density is zero, then flux is zero. Now, in that case, the net flux can be calculated as flux from the inner surface plus flux of the outer surface, same as here plus here that we began with. Now, in that sense, inner surface, if I know that is 4 pi q, then inner surface is oriented outward, that this orientation will be negative. So outer surface flux, that is velocity vector dot product with the area vector plus inner surface flux equal to net flux between this region or in this volume. Net flux is zero. Inner surface, now outer surface, that is outer surface f dot dA plus become minus, because inner surface we are interested in inward vector, that will be minus, because we are making it opposite, minus inner vector equal to zero. So outer vector flux is same as inner vector flux, because minus will go that side and it becomes same. Make sense? I am trying, if I know, okay, so I'll again repeat, because this is trillion dollars. What if I know flux density? Okay, consider this is origin. Consider here is the origin. Origin is here. There is a cylinder like this. I know flux density. Okay, consider flux density is zero. If it is zero, zero everywhere. Zero is constant. Now, what is the flux that is coming out of this solid region? Flux density, if I know, what is the flux that is coming out of this solid region? Flux that is coming out of the solid region is all of the surfaces. How much is the liquid oozing out? That is the flux. That is same as flux density into the volume. Okay, but volume, this is okay. Flux density is zero, and flux and velocity vector flux density is zero. But at the origin, this flux density is not defined. Make sure that flux, if you are calculating flux, if someone is calculating flux from the flux density, then that volume must not contain the point where it is not defined. So it is flux density is not defined at the origin, or velocity vector is not defined at the origin. Now I can go with multiplication. Now if flux density is 0 and this is not containing the origin, then flux density into the volume is the net flux coming out of it, that is 0. Similarly, if this flat region, if I mold it like a sphere, and this flat region, if I mold it like a sphere, then there are two spheres coming into the picture. The in between region of the two sphere, which does not contain the origin where the velocity vector is undefined, I can calculate the flux coming out of all over the surface of this in between region is the flux density into the volume. Flux density is 0, so net flux coming out of this region is 0. This flux is same as the flux that is oozing out from the outer sphere plus flux that is oozing out of the inner sphere. It has two surfaces, right? One surface inside, one surface outside, and in between the entity is there. For this entity, there are two surfaces. One surface is going out, and one surface is inside. That is again going out. But this going out is negative because this going out is positive. If you remember. Then question arising, what is the net equation now? The net flux that is coming out of this inner volume is flux density into the volume, that is 0, equal to net flux coming out of one surface plus net flux coming out of the another surface. Another surface and outer surface, they are in different direction. So plus will become negative. So net flux coming out of this in between region of the spherical region is flux density into volume defined for that volume region equal to flux that is calculated for outer sphere surface minus flux calculated minus because the direction is opposite minus flux calculated for inward surface minus if you take this side it becomes plus. Now inner surface flux and outer surface flux are same. If inner surface flux is 4 pi q, then outer surface also 4 pi q. We can calculate immediately why you did this much when we know that if there is a charge kept at the center and qr vector by r to the power 3 is the velocity vector. If you take any sphere, it is 4 pi q. Why you did like that? Okay, consider the outside. I talked about a sphere. Outside is not a sphere, it is ellipsoid. Instead of a sphere, it is an ellipsoid. If it is ellipsoid and its equation is x square by 2x square by 4 plus y square by 9 equal to 1. Then what is the flux that is coming out of the ellipsoid? Now the surface of the ellipsoid, whatever is flux, plus the flux from the inner sphere equal to the net flux here. Flux density is 0, so net flux is 0. Here inner surface is negative, it will go that side. Now again it will be same. So flux density of ellipsoid, that is the outer region now, will be again 4 pi q. So this calculating the flux, we will talk more on it. This is becoming very long, but this is how the energy calculus is. So this is how we can calculate the flux that is coming out of a surface that we cannot calculate in simple manner. That we go with the flux density to flux density to flux computation. If we go, then we can calculate through that fundamental. Okay, so I have a sphere. So scenario is if I have a charge that is kept at the center and charge power is q into r vector divided by r to the power 3, and there is a sphere kept at radius 1, and there is an ellipsoid that is kept outside it, and its equation is x square by 4 plus y square by 9 equal to 1, then what is the flux that is coming out of the ellipsoid? That is the question. Okay, then in between region we took the flux density, that is 0, and flux density is not defined at origin, but this region is not containing the origin, so this region net flux will be 0. That is equal to the flux density of the ellipsoid surface plus flux density of the this spherical surface, because these two are the surface of this in between region. One I know, another I can calculate because I know the net result. If it is not 0 also, if it net result, we know the plus addition, I can get it. People can think about it. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number, plus 91 is the India country code.